This is a video going over homework 2. Make sure to smash that like button and subscribe for future videos. So what we're going to do in homework 2 is we're going to be working with functions and we're going to be working with logic. Now to do that, it's going to be convenient sometimes to use NumPy and Matplotlib. That's these two imports up here. These are libraries. That's code people have written for us. And when we import them, it allows us to access that code very quickly and simply. So we're going to import NumPy as NP, storing the entire library on this variable name. We're going to import matplotlib.pyplot, storing that entire module as PLT. Alrighty, so for assignment 2, similar to assignment 1, there's a class that initializes a student object, and you're going to create yourself your student object here. So in the class, we can assign a first name, a last name, a UID, and an email. You'll put those in here and it'll create a student object that'll let me grade this in an automated fashion much easier. Okay, now moving on. In the homework, you're going to be building functions. You're going to be given a prompt that tells you what I expect of that function. So let's look at this first one. Q example 0. Write a function that returns the energy of light given its frequency. Okay, so we know that the energy of light can be determined by E equals h nu, where h is Planck's constant and nu is the frequency of light, so we're going to be using that relationship to build our function. First thing we do is we're going to define a function. Now I've already pre-written this and I don't feel like retyping it, so we're just going to go through the function I've written and you'll see what I expect from you here. So first, we'll define a function, energy of light, that's the function name, and you see here it says the function name should be energy of light, so I'll always use this as the function name, that way I can grade this easier. And then the argument to that function is nu. With the docstring, note the docstrings are these little green parts I've added here with denoted by a triple quotation mark and a triple quotation mark. This allows Python to know that it's a help statement if someone wants to use this object and doesn't have access to the code directly. Okay, so the parameter we're inputting is going to be this new value. It needs to be input as a float, meaning it's a numerical value with some amount of precision. And it's going to be the frequency of light. And note, I've added units so that you don't get lost and get the wrong units, therefore the wrong answer, and that needs to be in per seconds. And it's going to return an energy in joules. That means we have to retrieve a Planck's value that is in joules per second. So here we go, our function. Essentially what it does is when you hit run, it defines this help function for someone else. It defines h, and then it runs the equation E equals h nu, returning E. So there you have it. We've defined the energy of light. And then the next thing we're going to look is code block to determine whether function works as intended. This block of code from 56 to 67 contains code I've written for you to check if your function's working correctly. So what it's going to do is it's going to define a value of nu. It's going to call your function, inputting that argument, and it's going to create an answer. It's going to tell you what your answer was, and then this is the correct answer here on line 60. We'll check the answer. We'll ask to use NumPy. It's going to say, is it close to the correct answer? If they're close, within some tolerance to each other, we'll say you got it correct. If not, it'll tell you to check your code. So let's go ahead and run this cell. I'm going to go click on the cell and hit Control Enter. Okay, so we got our first error. Name NP is not defined. So I tried to call this variable before I defined things up here. So let's run the first cell, and it's going to import these libraries, and it's going to create a student. Perfect. Okay, now we can run this next cell, and there you go. You answered 6.62607 E-16. Example 0, you are correct. So we go down here, and we'll notice it doesn't quite match the correct answer, but it's within some tolerance, and so we got that correct. Excellent. Let's look at a second example. This one has us calculating the temperature-dependent diffusion coefficient. So essentially, this coefficient depends on an independent diffusion coefficient, an activation energy, and a temperature of interest. So we're building a function that, given a temperature, can return our temperature-dependent diffusion coefficient. So let's go ahead and do that. We're going to define diffusion. So again, here I'm told my function name should be diffusion. So I'm going to define a function named diffusion. I'm going to give it these arguments, d0, qd, and temp. So that is the independent diffusion constant, that is the activation energy for the diffusion, and that is the temperature. Those all need to be input as floats, and it's going to return the diffusion coefficient as a float, and that's the temperature-dependent diffusion coefficient. So here we go. The last thing we need for this equation is the ideal gas constant. We're going to have to keep track of units, that means. So that's joules, moles, Kelvin. And so our diffusion coefficient when it's defined is right here. And let's go ahead and look at the code block and see if we wrote this function correctly. So we're going to be given a D0, a DQ, and a temperature. Our QD, needs to be corrected because this QD is in kilojoules, but we need it in joules. So we're going to multiply by a factor of 1,000. This temperature is in Celsius, but we're going to need it in Kelvin, so we're going to add 273.15. And then finally, what we're going to do is we're going to run the diffusion given D0, QD, and temp, and see if our answer matches the true answer within some tolerance. So we're going to ask NumPy if it's close. If this statement is true, it'll run the print you are correct. Else, it's going to run check your code. So this is the code block to determine if it's working. From 110 to 129, you don't have to touch anything in here as long as your function works correct and is named correctly. And then I've added another little part, visualize our results. Let's see what this looks like. So I'm going to generate a bunch of temperatures with this line of code here. And then for each of those temperatures, so for each temp in the temperatures, I'm going to run my function and save it all in a list. When I do that, I can plot the temperatures and I can plot the result of my function, and we'll see what it looks like. So let's go ahead and click in here, and we're going to hit Control Enter while inside the cell. I could also hit Shift Enter if I wanted to go to the next cell as well. So it's going to run. The first thing it says is example 1. You answered 58346, and that's close to 5835, so you are correct. And we'll go up to plots here. Now yours may have plotted inline depending on if you're using Spider 3 point something or Spider 4 point something. I'm using Spider 4 point something, so the plots are up here. And we can see how the diffusion coefficient changes with temperature. So this is temperature 200 to 1600, and this is from 0 to 1, E negative 8. Now for the remainder of the homework, you'll be solving these types of problems. So this is where it's saying, oh look, undefined name Fahrenheit to Celsius. You're going to have to make this function, so you'll build your function here. And if the function's correct, when you run it, it'll print out these types of statements. So the same thing will happen with Q1. So you'll do Q0. You'll do Q1. This is the Pythagorean theorem. You'll do Q2. This is the quadratic formula you'll be building. Q3 is a little bit different. You'll be extracting information from a string value. And so your function is going to operate on one of these strings, and then you'll call your function multiple times to get all of these. But you just have to build the function. The rest of that happens inside the code block. So see here, this is where it calls your function multiple times for multiple files. So for each of the file in that list file names, it's going to call your function, and it's going to retrieve the values from it. So your function, as it says here, should return 2 floats. So a quick example what that might look like is you're going to have some function name, def function name. You'll have some arguments, but it's going to return 2 floats, a value A and a value B, just like that. Now you're going to have actual stuff in between, but this is how your function should look. And I'll do the parsing from there with this part. Okay, now as we move down, for question Q4, what you're going to do is you're going to look up the Project Euler problem 1. Now this problem will help you think algorithmically, and it's going to be using for loops and some logic to make sure that you get things right. You can check for solutions online. Now don't spend too long on this. If you're stumped and you've gone 10, maybe 20 minutes and you don't have a solution, you haven't even started typing, then go ahead and look at the solutions online and use them to guide and influence an answer. I don't want you to copy straight up, but once you have your own answer, you can then try to figure out what their answer did and implement something that ideally works pretty well. So again, once that's correct, once you've written in your function should be named sum 3s and 5s. This code block will ensure that you have the right solution. Now after that, we're not going to be checking your solutions. So Q5, Q6, Q7, and Q8, you're going to build on your own. Now you can check with each other, or you can always email me to see if the solution seems okay. But really what I want you to do with Q5 is build a function and make sure that function uses if and else statements. So here I've made a function that asks, are you a Scorpio? So you give the month and day, and it'll either say you're not a Scorpio, or it'll say congratulations, you Scorpio. So this is my function. I want you to have a function. It doesn't need to be quite so complicated, but it does need to use if and else statements. So I can run through this function very quickly. we're going to start with Scorpio being false. I don't know if you're a Scorpio, so I'll default to saying you're not. And then as I go through my logic, I ask if, oh, well, are you born between October and November? Then it's possible you're a Scorpio. If it's October, and if you're born after the 23rd, you are a Scorpio. Otherwise, you're not. If it's November and you're born before the 21st or on the 21st, before or on, then you are a Scorpio. Otherwise, you're not. And then I'm going to ask if Scorpio is true. Otherwise, if Scorpio would be false. So if it's true, you'll print off, congratulations, you Scorpio. Otherwise, or else, you'll print, you are not a Scorpio. And then I'm going to run the function, and here's the output. So you can go ahead and do the same thing for this question. And then finally, for Q6, Q7, and Q8, you're going to build functions that operate as an AND gate, an OR gate, or an XOR gate. Now, if you don't know what an AND gate is, you're going to have to look it up. But it should be pretty easy, and there shouldn't be too many problems, but it should help you think through logic statements. Okay, that should be the homework, and that should get you pretty far. As you have questions, just email me, and we'll go over it in class before it's due. So good luck.